Hi, my name is Khang and Tran, and this is my DA5030 machine learning final project. I download my datasets on the UCI machine learning repository. I downloaded two datasets, the immunotherapy dataset and a cryotherapy dataset. Both treatments were used to treat warts, and both datasets were very similar to each other because they're carried out by the same researchers. And some of the features that were in these two data sets were the gender of the patient, the age of the patient, time elapsed before treatment in terms of month, the number of warts, the type of warts, and the surface area of the warts, the induration diameter of the warts, and lastly, the response to the treatment, which I used to predict using my models, my KNN, my logistic regression, and my neural networking models. And the response to treatment was kind of a dummy code, categorical, a binary value. If it was a 1, it was success. If it was a 0, it was not a success. So without further ado, let me just demonstrate my project. First I installed all my packages. I visualized the data, and from a brief perspective of the immunotherapy data set, you can see there's not much correlation right here. The same can be said with the cryotherapy data set. So we would really have to dig deep in with the machine learning algorithms to really find out which parameters, if any, can kind of predict the success of the immunotherapy or cryotherapy approach. I checked to see if there was any missing data in the data sets, because if there was any missing data, I would have to perform data imputation or algorithms. But fortunately, the data sets were both clean. So from here, I prepare my training and testing data sets. I loaded it in, I cleaned it up, and I've made dummy codes for some categories such as gender, also the type of warts, because these are kind of categorical numbers. If it's a 1, then it's a common wart. If it's a 2, it's a plantar. If it's 3, it's both. So basically, I just made a separate category for all of them using dummy codes. And I did the same thing for the cryotherapy dataset. So next, I built a KNN model on my training datasets for the immunotherapy and cryotherapy datasets. And from here, the most optimal K value from the immunotherapy datasets in terms of KNN was 13 in terms of K value, and I made predictions on the test on my testing dataset. And this model turned out to have a 91% accuracy rate, absolute accuracy rate. But in terms of AUC accuracy, the KNN algorithm on the immunotherapy dataset was 62%. I did the same thing on the cryotherapy dataset using the KNN package from the KNN algorithm from the CARE package. And in this case, they said the most optimal K value was a 5. And I made predictions of the cryotherapy testing dataset. I checked for absolute accuracy by confusion matrix, and absolute accuracy was 86%, and AUC accuracy was also 86%. Next, the next model I used was a logistic regression model built on the immunotherapy and cryotherapy training datasets, and I then predict the results on the testing datasets corresponding to the immunotherapy and cryotherapy datasets. And I evaluate the model based on absolute accuracy and AUC accuracy. And first, I ran logistic regression on the immunotherapy training dataset. I used all parameters, but not all parameters were significantly correlated, were significant in terms of p-value. In this case, only time was. So I updated my model to include only time. And my model right here was much more significant in my model right here with time as the only parameter. It was shown in terms of p-value to be significant when predicting result. I applied my model on the immunotherapy testing dataset, and I got an absolute accuracy of 88%. with an AUC accuracy of 60%. And the same thing on the cryotherapy trained dataset. I did this many times, and the model that I finalized then involved age, time common type plantar. I used that model on my training dataset, and I got an absolute, I'm sorry, on my testing dataset, and I got an absolute accuracy of also 80%, but an AUC accuracy of 88%. Lastly, I built a neural networking model based on my immunotherapy and cryotherapy dataset. And the absolute accuracy was kind of lower on the immunotherapy dataset. It was 55% with an AUC accuracy of 42%. When I did the same thing on my cryotherapy dataset, I got an accuracy of 75% and an AUC accuracy of 75% as well. Okay, finally, I compared all three models in terms of absolute accuracy and AUC accuracy. Uh, and it turns out the KNN algorithm was a lot more accurate as opposed to the logistic regression models, but the neural networking models were kind of iffy. It was seems to be relatively inaccurate. Lastly, I checked my model based on cross-fold validations because my data sets were a little bit smaller. I only did a cross-fold validation of 3, and here's my function right here. First I loaded the data in, and I built my customized k-fold function that takes in the data frame. You have to indicate what model you want to use, KNN, or logistic regression, or neural networking, and the number of crossfolds. So I performed the 3 crossfold validations on the immunotherapy dataset, and from here I got an accuracy ranging from 66% to 83% with a mean accuracy of 76%. When I did the same thing on the logistic regression, I got a much higher accuracy, but neural networking was still kind of low, it's 56%. Finally, after I examined all my data sets individually based on KNN, logistic regression, and neural networking, I wanted to kind of use the model on a more real-life approach to see which treatment is relatively better, immunotherapy or cryotherapy. So I built my models based on the entire data set, immunotherapy and cryotherapy, and I combined all the wart values of both data sets into one master list. And I built a model based on that entire data set, and I applied it to predict the outcome of the master list. And my definition of success was if a treatment had more successful cases in terms of more ones, then it is more successful. If it has more zeros, then it's not as successful. And that was my my condition for success of treatment. And after I built my model on my data sets and I made the predictions on the master list, I would then create an ensemble in which I would just kind of vote on what prediction was the most common. So KNN votes for a 1, logistic regression votes for a 1, and neural network votes for 0. The ensemble would randomly pick 1 as the prediction. So first thing I did was, in order for me to create the ensemble, I loaded in the data set and I prepared it. I tried the immunotherapy data set based on KNN on the entire dataset, the entire immunotherapy dataset. I built a logistic regression model on the entire immunotherapy dataset, as shown from the code right here. And I built the neural networking model based on the entire immunotherapy dataset. And I pretty much did the same thing on the cryotherapy dataset. I built the KNN model, the logistic regression model, and the neural networking model on the entire cryotherapy dataset. After I built the models, I determined which treatment was better by creating a master list by combining the immunotherapy and cryotherapy data set combined, and I made a direct comparison between the two treatments, the immunotherapy and the cryotherapy data set, by my model ensemble. Shown this code right here. I loaded in my immunotherapy data set, my cryotherapy data set, and I just combined them together, as shown in this code right here. I then used the models that I built earlier on the entire immunotherapy and cryotherapy dataset, and I made predictions, as shown right here. And once I created my ensemble for all three models, immunotherapy, based on immunotherapy, I used kind of a voting system to find the mode of the most common prediction. So if KNN votes for a 1, logistic regression votes for 1, and neural network votes for 0, the ensemble will automatically determine 1 as the most optimal outcome. And I repeated this for the immunotherapy dataset and the cryotherapy dataset, and I tallied up all the results. And it turns out that the immunotherapy treatment was a lot more successful than the cryotherapy dataset. I basically pulled out a table function, and the immunotherapy had a lot higher success as opposed to the cryotherapy treatment. That was relatively successful, but it only had 102 successes, while the immunotherapy was a lot more successful. And that is the result of my, that is the main conclusion for my main project. Thank you very much.